Example 7. So we have to state the similarities and differences of double slit and single slit diffraction patterns. So the similarities are both of them are consisting of alternating dark and bright fringes, and then the center for both patterns for both interference is bright fringe lah. And then the differences is for double slit the width is the same, but for single slit the central fringe is wider than the other fringes lah. And then the next one, the intensity reduces slowly as distances increases from the central bright. And then the for single slit, intensity reduces rapidly as the distance increases from the central bright. So that is the differences. And let's solve for question B, which is asking us how many bright fringes will be produced on a screen if a green light of wavelength 553 nanometer is incident on a slit of width 8 micrometers. So A is 8 micrometer, and then we have the wavelength 553 nanometer, and then we have to calculate the number of bright fringes. So we know that this is the equation for maxima fringe. Okay, and then remember the theta should be 90° if we want to calculate the maximum number of fringe. Okay, so 8 micro sine 90°. So we are looking for the maximum number of fringe plus 0.5, which is just half, times this. So we will get the number of maximum number of fringe is 13.97. Round this up, I mean approximately 13 lah. Take the last number, okay? Don't round this up to 14, round it up to 13 saja. And then you will then calculate this. So the number of bright fringe observed is 13 times 2 plus 1. So why do we need to plus 1? Because we need to consider the central bright fringe. So you will get 27 fringes. Okay, so if it is maximum, which is the dark fringe, you don't have to plus 1 because it does not have a central fringe. So this is central bright fringe. Okay, so please remember that when you're trying to calculate the maximum number of fringes lah. Okay, all right, and that is on example number 7.